Welcome everyone! In this video I show you a smart little project which could make your life easier. The parts you can see on the bench will be assembled together into a nice little box which will serve as a nameplate. The purpose of the nameplate is to indicate your status and location, for example at your office. It is battery operated and you can update the status via Bluetooth using your phone, so you can put it directly on your door or something. I use the following parts in this project. Of course, a 3D printed enclosure. It also has a magnet that could be used to stick the device on something magnetic. I also used the Lolin32 ESP32 based microcontroller board. I picked it because it was cheap and it has a built-in battery managing circuit. I used a 2.9-inch e-ink display. It is a very low power display and it retains what is printed on it even after the whole device is switched off. I used a 3500 mAh LiPo battery. With a little effort, it keeps the badge alive for a long time. I also used an RGB LED. It is a PWM controlled LED that accompanies the display in indicating the status. And there are some other components such as a switch to cut the power from the battery and some resistors. So the basic concept is that I wanted to create a nameplate. So instead of always writing where I am or what I'm doing on the whiteboard next to my office door, I can just simply print this status update on the display using my phone. Then people who are coming to my office looking for me can just look at the display and see where I am. And yes, the whiteboard would still serve the same purpose, but it does not have the same cool factor. So let's look at the battery a little bit. So as I said, this is a 3500 mAh battery. It has quite some capacity. And when the device is started, its current consumption peaks to roughly 115 milliamperes. And then it seems to settle around 45 milliamps. So every hour, let's say we consume 50 milliamps. Every day, I'm in the office for like 9 hours or so. So the battery loses 450 milliampere hours per day. At the end of the day, I shut down the device. So during the night, there is no power consumption. So with a little rounding and safety margins, let's say the device can operate for 7 days. I can use it during the week and charge it during the weekend. So it's simple. But to not only rely on the calculations, I made an extra step here and I actually monitored the battery voltage, so I get a better feedback on the charge of the battery. Unfortunately, the ADC of the ESP32 is not too good, and I was kind with the choice of my words. It becomes nonlinear about 2.5 volts and it also has an offset. But before diving into these details, I must first highlight that we cannot measure the battery voltage directly because it is higher than the maximum allowed input, which is 3.3 volts. So this is where the resistors come in handy. I built a voltage divider, and here the information about the nonlinear behavior becomes useful because I should design the voltage divider in a way that the ADC should never experience higher voltages than 2.5 volts, so we stay within the linear region. So first I said that the voltage should not go above 2.4 volts, so I added an additional safety margin, and I also know that the battery during charging reaches 4.2 volts. So I set this value to 4.3 volts to add another safety margin. So basically I need a voltage divider that divides the 4.3 volts down to 2.4 volts. It would be ideal with, for example, a 1.2K and a 1K resistor, but I don't have 1.2K at home. However, I have 1.5K. So I will use that. This is a bit more division, so actually the voltage becomes lower, but the voltage still falls in the linear range and I have enough resolution, so it is okay. And then another part where we need to deal with resistors and the little calculations is the RGB LED. So it has 3 colors, red, green and blue. I guess it's kind of obvious, but those colors have different forward voltages. Therefore, we need to pick different resistor values to have the same forward current and assumably the same brightness. So let's say I want to run them at around 10 milliamps, and the red color has 1.8 volt as forward voltage. I looked up the datasheet, and the other 2 colors have 2.8 volts, both green and blue. So for the red color, we need 150 ohm resistor, and for the other 2 colors, we need 50 ohms. So I just pick the closest value components I have at home, and I will use those. So after a little assembly, here is the final result. The fit is almost perfect. I might do one more reiteration on the enclosure because I'm not 100% satisfied with the holes. Otherwise, it is reasonably okay. And I might also revise the back panel or replace the magnet because the current magnet seems to be not so strong to hold the whole thing up. But actually there is a cheat here that you can stick two magnets on the whiteboard, for example, which are supposed to be magnetic, and then stick the device on those magnets. And there you have a better attraction and it will hold the device. I tried it and it works. But now let's test this thing with the Bluetooth and see how it operates. And I will also show you the code, the Arduino code, in a few minutes, but before I want to show you how it works. So I made a few presets that I know I typically use. So to use those presets, I just need to send a simple character to the module. B is busy, and so on and so on. You can see it on the video. And for the location, I have another idea. I send a letter, small l, and then I put a space, and then I write a free text. And then the microcontroller takes this, let's say, array of characters and parses it into a printable text and then updates the location. It makes more sense to send a free text because it is just simpler. So I show you how it works, and I just send some random text to the display to demonstrate the concept. And for the name and the phone number, I kept them as hard-coded texts, so that is only changeable in the source code, because these parameters don't really change during the day. But based on the above examples that I will also show you in the code, you can implement an updating algorithm for the name and the phone number as well, if you want. So to actually see how the code works, let's go to my computer and let's go through the code. Alright, so here's the code. And in fact, it is quite simple because most of the code is recycled code, either from the Arduino examples or from the library provided by the VAct Studio, which is the developer of the e-paper, which I use as a display. So if you read my code, you will see a lot of details, and I even put some pins and descriptions in the code. So for example, you can see the SPI pins of the display here. And then if we go further down, we can see the rest of the code. So we have a bunch of libraries and definitions here. These are needed for the display and for the Bluetooth. And then here, I have these variables which are just borrowed from the example of the Bluetooth communication. If you want to look at that example, you can reach it from the Arduino IDE. I use this example, BLE_UART. And then we just have a bunch of variables here which make sure that the code knows about the status of the device, whether it is connected or not. Then I have a string which stores the message, the free text that we can send to the display, and then some flags again just to see if there is a new status or if we need to or can refresh the display. And then we have an RGB LED, so I made flags for that as well, both for the 3 individual colors and for the wall LED as well. Then we have these definitions taken from the example again, so I'm not going to go into too much details. And then here, this belongs to the display. And then I created a bunch of character arrays here. So this will be the holder for the name. So you can see that I have a fixed name there. And then these two, the status array and the location array, they are fixed in size because of the width of the display and the font size as well. But they are actually dynamic. So they can be updated from the Bluetooth connection or via the Bluetooth connection. But for example, the name array and the phone number array, you have to write it here. It's fixed in the code, as it is also indicated in the comment. And then I have the pin definitions for the 3 LED pins, so 12, 14, and 27. And then I use the pin number 34 for the analog to digital converter to measure the battery voltage. And for the battery voltage, I consider the maximum and the minimum value. I explained this while I showed you the setup, that I introduced some safety margins both upwards and downwards. So these values or these margins will also show up in the equations. And now I have the functions in a bit funny order, because sometimes the code was complaining when I tried to compile it. So first I scroll down to the setup, just so I can show you what is in the setup. So here we have our setup, and it has a serial definition here because I used the serial port to debug the code. But actually all the serial things can be removed because it is not used. When the device is in standalone mode, you are not connected to the computer anyway, so you don't need these messages. And then I turned off the Wi-Fi because that saves a lot of power. And then again, they are from the example, which I showed you how you can get it. The only thing I did, I just renamed this variable or this kind of argument here, because actually this is what will show up in the Bluetooth device name. So when you are scanning with your phone, this is what you will find as the name of the Bluetooth device. So then once the advertising and the Bluetooth service is started, the setup proceeds to the pin definitions. So all the 3 LED pins are outputs. Then I just print a debug message, and then I take care of the display as well. This is also taken from the display's example code, so nothing extraordinary. And just to be sure, I manually set the resolution of the analog to digital converter to 12. 12 bits are totally unnecessary, but yeah, I just did it. And then if we go further down, this is the loop. And then actually what the loop does is very simple. With these 2 if conditions, it is just looking for the disconnection of your device. So if the device is disconnected, and I will show you how that is registered in the code. So if the device is disconnected, then these variables will change, and then the ESP32 will start advertising its Bluetooth connection again. So then you can connect to it again if it's needed. But basically that's all. And again, just a debug message, so I know that okay, it was disconnected. So then the ESP32 starts to advertise its name again. So let's look at the code which makes the Bluetooth work. And that is, for example, this callback. So this doesn't do anything else. It's just if there is a connection, then the device connected variable becomes true. And if there is a disconnection here, then the device connected becomes false. And that is what will trigger that piece of code in the loop. And then we have this on write. And that is actually the part which captures the incoming characters. So what I do here, I fetch the variables from the Bluetooth in this received value variable. I just again let the serial port know that the onWrite, this function here, was fired. And then if there is something, so if we received something, then we first delete the content of the message. So I set it to basically nothing. And then I iterate with this for loop through the whole length of the received value. So whatever was put in the received value here. And then it steps through the received value character by character. So that's what we see basically here. So I equals 0, I equals 1, and so on and so on. And then we stick together those characters into a string. This might trigger a few people because Arduino and string is not the best buddies, but yeah, it works. And then just to be sure, I print the whole message, so I can check it on my computer that the message was successfully captured. And then I set the status to true, and I run my functions from here, so from this callback. I think that's the most efficient. So then I check for the status update. So what was the status that we need to update? Then we print the update on the display, and we also update the LEDs. So then let's check this status update checking function. So if there was a new status, and why I did this, because initially I put this function in the loop, but now it's actually not even needed because it won't be accessed, let's say, continuously, like as it was in a loop, but it is only called from the callback. But I just left it here because I'm lazy. So yeah, if the new status is true, then we enter. And then here comes the part where I send the characters. So basically what it does is that it checks the contents of the message string, and it checks the character at the 0 position, so the first character, like physically the first. And then if the character is A, then I say, okay, that's the available. And then I take the status array and I replace the whole status array. So I say that, okay, it will look like this. You can see that I put some extra spaces there. That's kind of empirical, like how many spaces I need there, because I looked at the display and then I checked when it looks like acceptable. And then already here I tell the code that, okay, now it can refresh the display and it can also update the LEDs. And then I just define my, let's say, a color code for the available status. So then if I'm available, then only the green part of the RGB LED can turn on. And then if I'm busy, again, status update based on the character. And then I turn on the red and the green LED at the same time inside the RGB LED. So that will become some other color than red or green. So the mixture of the two colors. And then I have a holiday status as well. Then I have a working from home or home office status. And then a gone for the day status if I, for example, have to leave a bit earlier, but it's not end of the, let's say, core working hours, then this is a good status to share. And then down here we have the text-based input. So as I said, you can also use a free text, and for the location we will use a free text. So we check again the first character in that message string, and it's L. So then that will correspond to the location. So then I created a temporary string here, which will look like this. And then I keep adding text to it with this line. And what this line does is that it starts from the 2 because we take the L and then there is a space after it when we send the message, and then the next character will be the actual location. So that's why we start from 2. And then we subtract 1 from the message dot length because there's a line break character or some ending character at the end of the message, and that we don't need to like parse or put it in the string. And then we convert the string into a character array because that's what the display can accept. And then I print this message on the display just to check it. And then I just update a few statuses just to do something. And then I reset the new status variable. So if this was in a loop, then it would not be entering in the next iteration because this would be false. And then we had that print update function as well. So that's this guy here. So first I configure the display. So I just picked my rotation, how I rotated the display in the enclosure. And then I picked some font and some color. And the color is not always relevant because, for example, my display is one color display, but some of these displays, same looking display and everything, they might have 2 colors as well. So for example, a mixture of red and black. And then I configure the dimensions, the text box X and text box Y coordinates, and text box width and text box height. So those are like dimensions and not coordinates. And then I just define my own X and Y, and then I run these 2 functions. And then in the actual printing, I erase the screen. So I fill the screen with white color, put the cursor to the X equals 5 and Y equals 30, and then print the name array in that location. And then if you have noticed, there are like 2 lines under the name. So that's how they are drawn. And then I switch to a smaller font here, and then I print the status. And then I move a bit further down, I print the location. And again, I move a bit further down and I print the phone number. And then also, if you have noticed, there was a battery icon in the top right corner. And actually that's a legit like battery status indicator. And what we do here is the following. So I have a voltage bar value, which is now 0 in the beginning. And I have a battery voltage. which can be fetched by this function. So once we pass the value of the get battery charge status to the battery voltage variable, then first we cap the values. So I want to make sure that if it reads more than 4.3, then whatever the value is, the value will be 4.3. And if it reads less than 3.2, whatever the value is, it will show 3.2. And this is because I will dynamically draw the icon of the battery. And if they get the wrong numbers, then the battery will look very funny. So I wanted to avoid that, and this is a way to avoid it. So after capping the value, I have a map float function, which you can see down here. And this is the exact same map function that the Arduino has, but that was originally good for long numbers, long type numbers. But this is now just modified for float. And then I passed the values. So this is the reading, and then minimum value, maximum value, and then minimum pixel and maximum pixel coordinates. And based on those, I draw the top of the battery icon. So that's the filled small black rectangle. So the positive side basically. And then I draw the shell of the battery. And then based on the dynamic values, here I fill in the battery according to the charge. So then based on the voltage value, the height of that black area inside the battery icon will change. And then I just print everything. So then this function gets us the voltage reading from the battery. And as I said, the ESP32's ADC is not the best. I think Arduinos or STM32s are much better, more reliable. So I had to do some tricks here to make sure that I can read, let's say, a reasonable voltage. And as I showed it also in the video, I had to use a voltage divider whose output voltage will be below 2.4 volts because 2.5 volts and below, the linearity is still good, the linearity of the readings from the ADC. So I said, okay, let's go a bit more further down from 2.5. So I go to 2.4. And then I calculated what should be the values for my voltage divider, but I did not have those values exactly. So I just picked a bit higher values. So actually my ratio for the voltage divider is a bit more. And because of that, the maximum voltage which I will read will not be 2.4, but it will be 1.74. That will be the maximum possible input voltage if my maximum possible input voltage for the voltage divider is 4.3 volts. And then the bottom will be around 1.2 if my input is 3.3 or 3.2. I don't remember the exact number. So after applying that dividing factor with these two resistors, which create a voltage divider, we of course also have to multiply back the voltage in the AD conversion. Because let's say the AD converter up to this part of the formula will return 1 volt. That is actually in reality 2.5 volts, because we actually curious about the input voltage of the voltage divider, and hence we have to multiply it with the dividing factor of the voltage divider. And then I have a magic number here, and that magic number comes from the fact that there's also some kind of offset with the ESP32's AD converter. And then I just physically measured some points, and then I saw that the measured voltage and the ADC voltage is roughly 1.148 times apart from each other. So if I multiply the ADC reading with this magic number, then I get the actual reading that I get with the multimeter. And yeah, that's that. I just return the voltage, and then basically it ends up here in this line, or more precisely, it ends up in this parameter, this variable, and then it just does what it has to do. And finally, we have this update LED function. This is very simple. If we can update the LED, Then we check which LED is on. Red, blue, or green, there is no other choice. And then, yeah, I just turn on one LED at a time. So if we assigned some status which turns this variable on, the rest will be off, because that's how I wrote the functions. Then we just turn on the LED for the red color and turn off the other two. And then you can extrapolate what will happen with the blue LED and the green LED as well, so I'm not going to explain it. And then after the LED updated, then we just put this variable back to false, because this function was also in the loop, so I wanted to turn it off after we did the update. So if you want a bit more details, also visit my website, because I wrote an article and I put some pictures there and calculations and probably a bit more explanation as well. So please check my website. And if you like this content and you want to further support me, please consider supporting me on Patreon. That helps me a lot. And also check the parts and tools page on my website, which you can use to buy relevant parts using my affiliate links, which also helps me. So I hope you found this video useful, I hope you learned something, and see you in the next video.